this lecture video, we're going to talk about unit circles, how to read them and their purposes within trigonometry and the whole scope of mathematics as a whole. Unit circles allow us to expand the domain and sine and cosine into the real numbers. So it allows us to read angled values using these trig functions, sine and cosine, to actually get tangible values from them. The unit circle is a handy tool to help us remember how these rules work. And this is something that unfortunately is things that you'll have to memorize throughout your career in mathematics, because this comes up very often and they will assume that you have learned this and understand it. So without further ado, let's get into the features of a unit circle and how to use them. The unit circle is a circle in between -1 and 1 as its domain. It uses cosine as it correlates to its x values and sine as it correlates to its y values, as you can see here. The x and y values within this unit circle always create some sort of right-hand triangle, which is obviously very important for trigonometry and allows us to do many trig properties with these triangles. Within the unit circle, there are a number of ways to represent the values that we get with the angles. You can either be given it in degrees, radians, or as an ordered pair. The degrees and radians for the unit circle go as follows. They move as 30 degrees, 45 degrees, 60 degrees. Then after 90, it goes 120, 135, 50, and then so on and so forth. The real pattern here is you can be taken with just one of these segments. So if I'm giving you advice as like a math student, I would not try and focus on memorizing like every value of the unit circle, but just focus on memorizing the patterns and methods to solve the first quadrant right here. And then once you can do the first quadrant, getting all the other values from the other quadrants is much easier and more like intuitive, I would say. Again, cosine correlates to the x value. So cosine of 0 degrees or 0 radians is the 0.10. So certain values you should be able to pull off the top of your head, because they're very fundamental for math in the future. And then similarly, cosine of pi over 2 or 90 degrees is 0 because we're at the y-axis. And then inversely, then sine at 90 degrees is 1 and sine at 0 degrees is 0. Because remember, this value correlates to your cosine and this value correlates to your sine when it comes to the ordered pair. This is how we view the quadrants of the unit circle. Again, the unit circle is between -1 and 1. And the radian, or the degree radians for each quadrant, will go from 0 to pi over 2, pi over 2 to pi to 3 pi over 2, and 3 pi over 2 to 2 pi, which just makes up every quadrant here, broken up by 90 degrees each to give us our full 360. So oftentimes in trig and your math classes, they'll give you directions and angles by just giving you the radian. So it's important to know where the radians fall in correlation to like the degrees as well. So if they gave you something like, 3 pi over 2, you should immediately know that it's this part of the unit circle. Or if it's like 7 pi over 5 and stuff like that, you should know where that falls within the unit circle. Similarly, the unit circle follows the same rule as an x and y coordinate graph. Up here represents the positive x and positive y direction. Down here is the negative x and negative y direction. Negative x, positive y, positive x, negative y. So all of those rules from typical XY graphs also correlate when reading the unit circle. And then just as an obvious reminder, this is trigonometry where we're using the unit circle to represent everything as triangles. So cosine, which again correlates to our x value coordinate, is in math, not in science, but in math, always treated as the adjacent or x value. It's always the adjacent side, but in math, we'll always refer to it as the x value. And then the sine will refer to the opposite side, which gives you the y value. So if I said cosine theta is equal to what? Cosine theta is adjacent over hypotenuse right here. And then sine theta would be opposite over hypotenuse. So then if I'm trying to find, like, if I'm just given the hypotenuse and an angle and I wanted to figure out what the x and y coordinates are, I would say the x coordinate is the hypotenuse times cosine theta, and that gives me my adjacent value or my x value. Similarly, if I'm wanting just the y value of this triangle and I don't know it, but I know the hypotenuse and I know the angle, then I could do the hypotenuse times sine theta to get the opposite value, which gives me my y value. Learning these or memorizing these rules right here is kind of like crucial, and will be expected of you to have it memorized. In like earlier grade school, they might have taught you something like Sohcahtoa, which goes like, like this. Oops, this is H, not A. So the way you read Sohcahtoa is that if I'm referring to the sine trig function S, then it's opposite over hypotenuse. If I'm referring to the cosine trig function, it's adjacent over hypotenuse. And then I haven't talked about it, but tangent right here, if I'm referring to the tangent trig function, it's opposite over adjacent. Or tan theta is equal to sine over cosine. Because if you put sine on top of cosine, the hypotenuse portions would cancel out and you'd be left with opposite over adjacent. In this slide, you can see how these triangles relate to the unit circle. Again, every angle within the unit circle just gives us a triangle to look at, where we have a hypotenuse, an adjacent side, which gives us our cosine values, and an opposite side, which is warranted by our sine values. That, I believe, wraps up how to read an introduction to unit circles.